Wasabi, you guys. I'm going to show you 10 derivatives that you must memorize by heart for integration B. The first derivative I want to show you is 1 over x. And the derivative of this is it's the sign alternates, so it's negative. And the reason why the sign alternates is because x, if you write this in exponent form, it's because of the negative exponent. And then it becomes x squared because when you derive this, it's negative, and then you're minusing 1 again, subtracting the power. And so our derivative is negative 1 over x squared. So the derivative of 1 over x is negative 1 over x squared. You're going to have to use this a lot, especially when you're learning square-square technique, where you have to do u equals x minus 1 over x, and you have to remember or understand that you have to make your du needs to be 1 over, your du needs to be 1 plus 1 over x squared. Again, the sign alternates, so don't forget about that. The sign alternates. Right? If this was plus, then this would be minus. Okay? So a very important derivative to memorize for integration B. 1 over x, the derivative of 1 over x is negative 1 over x squared. Second derivative is 1 over x squared. Okay, this is mainly for like a power rule. Like let's say that you did a u substitution and you come across like u squared or something like that. I'm sorry, not u squared. This pretty much, or some other u substitutions. But in general, it's good to have this in the back of your head. When you work with problems from like very advanced or competitive integration Bs, this is very useful to memorize when you're speed integrating. So the derivative of this, again, the sign alternates because of the negative exponent, and then it is x cubed. Now be very careful, it's not x cubed, it's 2 over x cubed. Okay. The reason why it's 2 over x cubed, there's a 2 here, because when you derive it, that 2 comes out. So yeah, the derivative of 1 over x squared is equal to negative 2 over x cubed. Again, you'll be, if you practice a lot of integral problems, you're going to come across this so many times where you'll just end up memorizing it. Okay. Next derivative is square root of x. A lot of u substitutions, you're going to be doing a lot of u substitutions like u is equal to square root of x. You're going to be doing a lot of u substitutions like this so many times. So it's best to memorize the derivative of square root of x is 1 over 2 square root of x. Okay. So it's 1 over 2 square root of x. Okay. That 2 comes from the exponent, right? If you derive this, that 2 comes out, and when you subtract 1, it is now a negative exponent. So that's why it is underneath, and the 2 is right there. So the derivative is 1 over 2 square root of x. Next derivative is x ln of x. Now, this is probably weird. Why are we memorizing this? This is very non-standard. But if you really want to do competitive integration B, you're going to need to know this. Okay? It's very good. You'd be very surprised how many times this shows up, where you have to do u equals x ln of x. Okay, so the the derivative of x ln of x, it's actually quite nice. The derivative of this is just 1 plus ln of x. And that's why you see it a lot in integration bees, is because when you do problems like this, it looks so weird, right? Okay, x ln of x plus 1, ln of x plus 1, right? And you wouldn't even see this. This looks so odd, right? But it's just a u substitution. Let u equal x ln of x plus 1. Then du is just literally in front of you. And so this is just, the answer is just ln of x ln of x plus 1 plus c, and you're done. So it's a very, very good derivative to memorize by heart, is that derivative of x ln of x is equal to 1 plus ln of x. And this is just by product rule, right? It's 1 because the derivative of ln of x is 1 over x, so it becomes 1. And then it's just ln of x because the derivative of x is just 1. So by product rule, the product rule makes it look very, very clean. So, but it's very good to have this derivative memorized. The next derivative is sinh. And you know what? I might as well add cosh as well. But in most schools, they don't teach you hyperbolic trig. They don't, ever. You never learn hyperbolic trig in a regular calculus class, right? Maybe at MIT, but like in most schools, they don't teach you hyperbolic trig, right? But if you want to do competitive integration bee, they're gonna throw this. They're gonna throw this at you. Trust me, they're gonna throw this at you. So, it's actually a lot easier than regular trig because, you know, like, okay, the derivative of sine is cosine, the derivative of cosine is negative sine, and you know, it's this that bothers a lot of people. But definitely memorize that too, because that's necessary. But here, it's easier. It's just cosh. It's just cosh, right? And the derivative of cosh, it's just sinh. It's just sinh. And the reason is because these are exponential functions. That's why. So like cosh of x is equal to e to the x plus this, right? So these are just exponential functions. So that's why their signs don't alternate. These are trig functions, right? If you put this in exponential form, they have a complex number. They have a complex number, okay? This I, complex number, is what's causing them to alternate signs. That is why. Because sine of x, trig functions, they're not exponential functions. These are exponential functions. So that is why they don't alternate signs. So the derivative of sinh is cosh, the derivative of cosh is just sinh, and you're good to go. Okay, very useful to memorize by heart if you want to do competitive integration bee. Okay, the next derivative is inverse secant. Now, some of you may say this is considered a standard derivative, but you'd be very surprised how many classes they don't make you memorize this, right? But in integration bee, this you're gonna want to memorize this derivative, right? And that derivative is x squared minus 1. Okay. It's x square root of x squared minus 1. And the reason why I brought this up is because when you do u substitutions, or when you do trig substitutions, let's say. Oh, not trig substitutions, just mainly u substitutions. But you might end up with things like this, or maybe plus whatever when you do after you do use substitutions and splitting. But this it's good to have memorized so that you can immediately say, oh, this is inverse secant, right? If you don't have this memorized, then you literally have to do an extra step, which is doing trig substitution, that u equals secant theta, and then you're going to have to, and then you realize, wait a minute, this all comes down to 1. Oh, wait a minute, it's theta inverse secant. So you might as well memorize this. So memorize this, okay? In very competitive integration B, you're gonna they'll pull this at you, and you're gonna have to do like integration by parts, and you're gonna have to derive this. But if you don't know the derivative of this, then you're screwed. So definitely memorize inverse secant. It's very useful. Next, again, I don't know why I wrote an integral, but again, some of you guys may say this is quite standard. Again, you'll be very surprised. A lot of classes don't. They don't really make you practice this. But if it's just for any number, like a, like 5x, then the derivative, I don't know why I wrote ln of a. That's wrong. The derivative is a to the x ln of a. So 5x, right? If you're doing let u equal 5x, then du is equal to 5x times ln of 5. Okay? It's ln of 5. So don't forget about that. Okay? E to the x is different because then if you derive this, you get ln of e, and that's just equal to 1, which is why it's always forever e to the x. Okay? Here, it's ln of 5. So you have to have this as a coefficient. So the derivative of a to the x ln of a. Okay? Especially when you want to do Feynman technique, this is a must memorize. This is a must memorize. So definitely memorize this by heart. Next derivative, x e to the x. Okay. Here, I mean, maybe the product rule is not so terrible, because you could just do product rule in your head. Okay, e to the x e to the x. Oh, okay, right. But it's good to, at the same time, it's also good to sort of memorize this by heart, right? You're probably thinking, oh, okay, if I let u equal x e to the x, I can just do product rule. Like, I don't have to memorize this. Oh yeah? Well, if I give you something like this, right? And let's say let's say if I make this even a lot harder. Okay. X plus 1. X squared e to the x e to the negative x. Okay. If you didn't have this memorized, then you wouldn't even see this coming, right? You wouldn't even know the derivative of this would equal e to the x plus 1. Oh, I needed e to the x, I needed e to the x here. Oh, and then this would cancel out. Oh, it's going to be an inverse tangent of x e to the x. But if you did not have this memorized, you would not see this coming. You would not know. You would be dumbfounded. You wouldn't even know what to do. All right, next is the derivative of inverse sinh. Okay. If you remember the derivative of inverse sine, which you really should, this is 1 over 1 minus x squared, right? So then this is actually very easy for you to memorize. This is square root of 1 plus x squared. Okay, this is very useful so that whenever you come across an integral, let's say, oh, I did u substitution, and then I end up with du square root of 1 plus u squared, right? Most people would do, okay, let's do trig substitution, u equals to tangent theta, right? But you could just say, oh, this is just inverse sinh, and then plug back u. You don't have to simplify anything further. You don't have to simplify anything further. Just let u equal, just plug back u, and you're done. You're good to go. And then you'll beat your opponent faster than they can. So definitely memorize this to avoid an extra trig sub step. So the derivative of inverse sinh, it's just 1 over square root of 1 plus x squared. Okay? All right, this may seem crazy. This may seem crazy, but the last derivative I need you to memorize. This may seem crazy, but you'd be very surprised how many times you'll see this in integration B. Please memorize x to the power of x. Okay, the derivative of this is x to the x times ln of x plus 1. Okay, so it's like this is like the derivative of this, except that you have this multiplied to it because it's exponential. But the reason why this comes to be is because x to the x, so x to the x is equal, if you do a loophole log, right, then take the exponent out. It's a logarithm law. Oh, it's a chain rule of the derivative that I showed you. It's the derivative that I showed you before that you must memorize by heart. Okay? Oh, so this is, by chain rule, this is e to the x ln of x times the derivative of the inside, which is ln of x plus 1. Right? And again, this is equal to that. So definitely memorize your derivative. I can't undo any further, but definitely memorize this. The derivative of x to the power of x is equal to x to the power of x times ln of x plus 1. And those are all the 10 derivatives that you need to know by heart to do very good in integration B competitions. Thank you for watching, and I'll see you guys in the next video.